Here we go. In this video, we're going to learn about Khan's algorithm. So Khan's algorithm is used to detect a cycle in directed graph, and it is also used to find topological sort. So what is topological sort and how do we detect a cycle? So we're gonna learn these two things in this video. So first let's look at the problem statement. We have this problem, cycle in directed graph. So you have given a directed graph with v vertices numbered from 0 indexing and e edges. We need to check if it contains any cycle or not. A graph is represented as a adjacency list where the element contains a list that are directly reachable from vertex I. Specifically, a element represents a edge from I to j. So let's look at the test case. We have given this. So this is a graph representation. So as you can clearly see, we have a edge from 0 to 1, 1 to 2, 2 to 3, then 3 to itself. So 3 is a cycle. So 3 to 3 is a cycle. We have a edge from 3 to 3 itself. So that's why we have to return 1. In this case, we don't have a cycle, so we just need to return 0. So let's look at the Khan's algorithm. How are we going to solve this question using Khan's algorithm? So first, let's take a graph. This is a directed graph of zero-based indexing. So now we have this graph. So then we will first, in our first iteration, we find in degree of each and every node. What's the in degree? Incoming edges to a particular vertex. How many incoming edges are there? None. How many incoming edges are there? 1. How many incoming edges are there? 2. How many incoming edges are there? 3. How many incoming edges are there? 1. How many incoming edges are there? 0. How many incoming edges are there? 2. So we have 0 and 0 here. So it means this is our starting point. We will start from this particular vertex. Then we will try to find whether there's a cycle present or not. So same applies on the topological sort. So first let's try to understand what is topological sort. So we have a question. There's a urgency list of a directed acyclic graph. It is given that we don't have a cycle in this question where a element contains list to all the vertices. So same adjacency list such that there exists a directed edge. Yes, we need to return topological sort. What is a topological sort? There's a description. It's a directed acyclic graph is a ordering of vertices. It's just a ordering such that every directed edge from u to v, u comes before v. So if there's a edge from u to v like 1 to 2, so then every vertex of u, every vertex of u means 1 comes first, then it comes to 2. So then we will print 2. As there are multiple topological sort, we can print any of them and it will just detect whether we have given correct or not. So we have given this. So first we have 1 to 0, 2 to 0, 3 to 0. So we can start from any given point. If we start from 1, 1 will come first before 0, 2 will come first before 0, 3 will come first before 0. So this is a valid topological ordering, or this or this. So there are 3 valid topological sorting. In this graph, what we have? We first have there are 2 topological sorting, so we can return any of them. It represent 4 will come first before 5 0 1 2 3. So 4 will come first, then 0. So there's a edge from 4 to 0, 4 to 1. So 4 come first before 0 and 1. Okay. Then 5 to 0, 5 to 2. 5 will come before 0 and 2. So 5 comes before 0 and 2. Then for 2 comes before 3. Okay, we have 2 comes before 3. So same applies for each and every node. 1 comes before 3, 1 comes before 3. So it's the same thing, and we just need to so topological sort, we will solve this question in this particular video also. So now first of all, now let's continue our Khan's algorithm. This is our starting point. We can start from this particular vertex. So we pick the vertices whose in degree is 0. So add vertex whose in degree, so in degree is 0. So add, so I will add these vertices in my queue. So I have a queue, and here I will add 1 and 6. Then this is my queue. I will pop out this node. Okay, I will pop out and that just print. So this node will pop out and I will just print it. Then we have this node. I have just I am done with this node. So what I will do, I will just uh, check its neighbors. So there's a neighbor 0. So I will decrement the neighbor degree by 1. So what it means is, I will assume that I am erasing this node. So it's in degree. As I have erased this node, so there is one less incoming edge. So there is one less incoming edge. So now it's in degree 0. I will add this node. It's in degree 0. So our next starting point is this. So then I will again check to I will again check uh, to find next starting points. So then subtract, then decrease neighbor in degree, neighbor in degree. So that's it. So now if I have to erase this, so in our first step I will do this and I will just erase this in degree. So let me change color to green. So I will change its in degree. So now it's in degree 0. I will add this particular node. Okay, I have added this particular node. Then what will I do? So I have added this node. Then I will pop out my next node. Next node is 6. Okay. Then I will print 6. So 6 neighbor node. I will assume that I have erased 6. So its neighbor nodes in degree will get decreased by 1. So it will be 0 and it will be 2. So now this is our starting point. Our next starting point will become this node. So let me change this. This will become 0. This will become 2. So this will be my new starting point. Okay, just add it. Then next pop out node is present here. So just pop out this node, add it here. Okay. Then decrease the neighbor in degrees. Okay. Okay. Then pop out next node 5, print it, decrease its neighbor in degree. So 5 neighbor is only this. If the in degree is 0, so I have again I have one more step. If in degree is 0, then add neighbor. So add this neighbor. I have added this neighbor here. So then I will pop out. Okay, I have popped out this node. So then I will print it. I will decrease the neighbor in degrees. This and this. This is our neighbors. So just decrease. Okay. Then so its in degrees now becomes 0. So I have added this. Then we have this. I will pop out, print it, decrease the neighbor in degree. So neighbor is this, decrease it, add it. Then remove, print, remove, then print and decrease the neighbor. So there is no neighbor. So this is our ordering. So these nodes we have visited. These many nodes we have visited. So this is our topological sort, you can say, if there is no cycle. So how? Like 1 comes before 0, yes. Then 0, from 0 we have 2 and 3. So 0 comes before 2 and 3. Then for let's say 5, 5 to 3. So 5 must come before 3. So let's say this. So 2. 2 to 4. So 2 must come before 4. So this is our topological sort if there is no graph. How do we detect a graph? So let's say we have this graph. How do we detect a negative cycle? How do we detect a cycle? So let's say we have this. Then what's the in degree of this? 1. What's the in degree of this? 2. What's the in degree of this? 1. What's the in degree of this? 2. 0. So this is our starting point. I will just add this in my priority queue. I have added this. Then I will pop out and print it. So in this question we don't need to print it. We can just check the counter, how many nodes we have visited. So I have visited one node, visited nodes, first 0, then we have 1. So I will assume that I have deleted this, so its neighbor will be 1, and no other node will added in my queue. No node added, my queue becomes empty. The total number of nodes is 4. Here, total number of nodes is 4, but I can only visit one node. All the other nodes may, no, of course, create a cycle. That's why we cannot visit that particular node, because there's a edge in the cycle. So that's why we cannot visit these cycle, the nodes present in a cycle. So if total number of nodes is not equal to visited nodes, if we have not visited all the nodes, just return this. So it will check. If it is not equal, it means there's a cycle, and it will just return true, there's a cycle present. So now let's look at the code. We need to detect a cycle. So what we got here, we have n and in degree. So we are using for each loop in the adjacency list. Then we are finding this destination node. So I will just add the in degree to the destination node. I have a queue. I have added a node if the in degree is 0. So this is my starting point, and I will count how many nodes we have visited till now. While our queue is not empty, just pop out a node, increment that we have visited this particular node, then go to the neighbor nodes, decrease the neighbor in degree. Then if the neighbor in degree becomes 0, it will be our new starting point. So just add it into the queue. After that, if we have not visited all the nodes, our count is less than n. So just return true, means there's a cycle. We cannot visit all the nodes. So this solution will just work fine. So now let's talk about time and space complexity. We have this for loop, it will be v plus e. We have this order of v, then we have priority queue. We are visiting each and every node by only once. So the time complexity will be order of v plus e, which is the maximum due to this for loop, and the space complexity is v plus e. Why? In the in degree we have order of v, then here here also we have order of v. So the space complexity will be order of v itself. So v plus v we can say. So that's about the time and space complexity. We have solved cycle in directed graph. What about topological sort? I will just copy the exact code here. So just copy the exact code. We have this code. Then I just need to do small modification here. I need to return a list. This will be topological sort. So just create a list. This will be my answer list. Then whenever we visit a node, just add the ordering here. So I've added the ordering of nodes. Then we don't need to return the we don't need to return true or false. We need to return a list here itself. So this code will work fine. Then the time and space complexity is exactly the same, and this solution will just work fine. I will attach the code in the description box, so be sure to check out the code. Before that, try to code it yourself first, and if you face any difficulty, take a reference of my code. If you like this video, give it a thumbs up and subscribe to this channel. And we have successfully solved this question. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching.